Hi everyone. In this video I will show you how to determine the tangent line using derivative. I will focus on trigonometric functions in this video. So first function we have f of x equal cosine x, and we need to determine the tangent at x equal pi over 3. So the first step, we need to find the derivative of that function. F prime of x equal, the derivative of cosine x is minus sine x. The second step, we need to plug x equal pi over 3 into the derivative in order to find the slope. So the slope, I will call it m, equal f prime of pi over 3. And I will plug x into this derivative, minus sine pi over 3. As we know, sine pi over 3 is root 3 over 2. So minus root 3 over 2. And this is the derivative, this is the slope of the tangent at x equal pi over 3. Next step, we need to determine the y coordinate of that point at x equal pi over 3. And we determine it by plugging pi over 3 into the main equation. So x equal pi over 3, the y coordinate is equal to cosine pi over 3. And cosine pi over 3 is half. So now we have the point pi over 3 and half. And this here, I will call it x dot, and this y coordinate, I will call it y dot. Now we determine the line equation, and the line equation we determine it by plugging first y minus y dot equal m into x minus x dot. This is usually how to determine the equation line, where x dot y dot is this point and m is the slope which we found it previously. So y minus y dot is half, equal m, we calculated it, which is minus root 3 over 2 multiplied by x minus x dot, which is pi over 3. And this is the equation of the line. Of course, we can either keep it like that, or we can just simplify it into the other form. Let's solve another equation. Let's say we have a function that is equal tangent x to power square, and we need to find the tangent at x equal pi over 4. So the derivative is equal to, here we have a function having a power and an inside function. So we need to apply the chain rule. 2 into tangent x, 2 minus 1 is 1, multiplied by the derivative of the inside. And as we know, the derivative of the tangent is secant square. So this is the derivative for that function. Next step, we need to find the slope, which I will call it m. And finding the slope is by plugging at x equal pi over 4 into the derivative. So f prime pi over 4 is equal to tangent pi over 4 multiplied by secant square pi over 4. So the slope is equal to 2. Tangent pi over 4 is 1 multiplied by secant square pi over 4. As we know, secant is equal to 1 over cosine pi over 4 into square. So m is equal to 2 times 1 is 2. 1 over cosine pi over 4 is root 2 over 2. All is square. And that will give me 2 into 2 over root 2 square. So m is equal to 2. 2 square is 4 over root 2 square is 2. And that 2 cancel that 2, so we'll have the slope is equal to 4. Next step is we need to find y coordinate where x is pi over 4. And we find it by plugging pi over 4 into the original function. So x equal pi over 4, y equal tangent pi over 4 square. Tangent pi over 4 is 1 and square. 1 square is 1. So the point we have is pi over 4, 1. I will call this is the x coordinate, I will call it x dot, and the y coordinate, I will call it y dot. Now we determine the equation of the line by having the equation y minus y dot equal m multiplied by x minus x dot. Now we plug these values. Y minus y dot is 1 equal m, we have found it, which is 4 multiplied by x minus x dot is pi over 4. And as I said, we can keep this equation in this form, or we can change it to another form. It's called the m slope, or the slope equation, mx plus b. We can change from this form to this form by simplifying this equation. So y minus 1 equal 4 times x is 4x minus 4 times pi over 4 is just pi. Then I can move this minus 1 into the right side, so y will be equal to 4x minus pi plus 1. And this is the equation of the tangent. Of course, we don't need to change pi into decimal. We can keep it in this form. Let's solve one more problem. Now we have a function that includes exponential function and trigonometric function. Ex multiplied by cosine x. Finding the derivative, let's say this is f of x. So the derivative is equal to, so since we have multiples, so we'll apply the product rule. The derivative of the first function is ex multiplied by the second function as it is, plus the first function as it is multiplied by the derivative of the second function, and the derivative of cosine is minus sine x. So this derivative, I will simplify it. It will be ex multiplied by cosine x plus minus, since plus minus multiplied by minus is minus, ex multiplied by sine x, and this is the derivative. Now we can plug this value x equal pi over 2 into the derivative to find the slope. So the slope, I will call it m, is equal to f prime of pi over 2 equal e to power pi over 2 multiplied by cosine pi over 2 minus e pi over 2 multiplied by sine pi over 2. So m is equal to e pi over 2 multiplied by cosine pi over 2 is 0 minus e pi over 2 multiplied by sine pi over 2, which is 1. So the slope is equal to 0 times e pi over 2 is 0 minus 1 times e pi over 2 is e pi over 2. So the slope is equal to e to power pi over 2. Next, we need to find the y coordinate of that point. So we have x equal pi over 2. We plug that value into the original function to find the y coordinate. X equal pi over 2. So the y coordinate is equal to e pi over 2 multiplied by cosine pi over 2. And as I said, cosine pi over 2 is 0. So e pi over 2 multiplied by 0 is 0. So the point is pi over 2, 0. And this is the x dot, y dot. Now we plug these values into the equation of the line. Y minus y dot equal m multiplied by y by x minus x dot. Y minus y dot is 0 equal the slope we have found it's minus e pi over 2 multiplied by x minus x dot is pi over 2. So the equation of the line is e equal minus e pi over 2 multiplied by x minus pi over 2. And this is the equation of the tangent for that function at the given point. I'm Hatem Omari. Thank you for watching my video about finding the derivative or finding the equation of tangent using derivative. If there is something not clear in this video, feel free to watch it as much as you want. If you like this video, please click on like or subscribe at my channel. Thank you.